Alright, so here we're looking at the 2021 paper for chemistry unit 1. Right, so let's have a look at this. The first question speaks about beta decay. For beta decay, we're going to have an increase in the atomic number, because for beta, we're going to have, well, neutron being created, the proton and the electron, right? So we know that the neutron's atomic number would be 0, mass number 1. And then these would be equal here, the mass number is 0, -1 here. So it's going to be transported, so the mass number remains the same, but we see that the neutron number changes by 1. A is the answer. Number 2, C would be the answer for this. Number 3, we're seeing that copper would be 4s2, but we lose from the 4s first, so it would be C as the answer. Alright. Here we're looking at tripling this, right, to around what, -330, right? And then this would be in this equation, it would be the reverse. Therefore, it should be positive 822 minus negative 330. That should give us positive 492. Here we're seeing that an increase in shielding decreases ionization energy, as well as an increase in distance decreasing ionization energy, but an increase in nuclear charge would increase ionization energy, so 1 and 3 are correct. Here we know that the 1 net of water to be 104.5. Here the halides, we're seeing that the halides here, ammonia would have a higher bond. We know that this is a disputed question, so I'm gonna just start. If you have an issue with this question and the answer, you can just say in the chat. So I am going to say that there is I don't think we can say hydrogen bonding, because hydrogen bonding would technically exist in most of these, right? But would say that it has more extensive hydrogen bonding. I'll go with there are more London dispersion forces are similar to Van der Waals forces, so I'll go with that. Hope I'm not going too fast. Here we're gonna see group. Is it gonna be group 1 metal or group 2 or transition metal? For this. Alright. So you have to look at the ionization energy, you know. So the ionization energy is our transition metals, right? You're gonna have some weird energies specifically. Let me see. Let me think about this. If you look at the energies of like transition elements, right? Let me think about this. So the first ionization energy. Okay, some persons would say that because it's a huge group, it's going to be a group 1 metal. So let's go with that. If there is any evidence to support that it's a transition metal, can you guys please state it in the comments section? Here we looked at the ratio for this. For this one, it's really peculiar. We said that we looked for the mass, the molar mass of calcium sulfate, right? The molar mass of calcium sulfate should be what? 40. Let me see. 40. Around what? 40 plus 32. That should give us 72. Right, now we're adding 8 times 4 plus 72. Hold on. Right, we need to find that first. So I have to find the molar mass of calcium sulfate, and I think that's 136, right? So it should be around 136, right? So we're gonna find the moles that represent. So it's gonna be mass over molar mass, I believe. So it's 68.0. 68.0 divided by 136 should give us 0.5, right? And the mass of water would be this out. So let's look at this, right? So for the molar mass of calcium sulfate, we're gonna have 136 grams, well, grams per mole, right, per mole, right? And we have to look at the difference here. In order to get the water, we'll look at how much water is removed, 68, right? So we're doing it, not divide it, we're gonna subtract it, we're gonna get 18 grams from this, right? And that would translate into around, yeah. So let's see this. In order to get the grams of water, we know that it's going to be 18 divided by 18, right, to get 1, right? This is a mass of water, because water's molecular mass is 18, right? For calcium sulfate, the calcium sulfate by itself, we need to find how much is in that 68. So we're going to divide its molar mass by 68.0, which should get 0.5. In order to find the mole ratio, we have to have 0.5 to 1, right? In order to get the full ratio between it, we have to divide everything by the least amount of moles. So if we divide that 1 by the least amount of moles, we must get 2, and 2 will be the mass of water here. 10. Which of the following compounds has a giant molecular structure? Silicon oxide. Here we're looking at Q plus P, right? In order to overcome, you must, well, sorry about that. You must get over, right, Q and P, right? If there's any issue with this question and you have a more plausible answer, you could state it, because everyone's not perfect, right? So let's look at this. The lines of spectrum. The lines in the spectrum become closer, they converge at the shorter wavelength at the end of the spectrum, because we're seeing that the difference between energy successful levels get less. So we start to see something like the Lyman, then the Balmer, then the Passion, and then as we increase, they get really small. This causes the difference between individual levels, right, decreases. The gas syringe, we're looking at P1V1 equals P2V2, and what we were saying here is that we have to find V1. So the initial pressure was that in atmosphere, so we have to convert this atmosphere, right, to pascals, right, to work with. So if we have 0.49, right, so if 1 atmosphere is 101,325, 0.49 is what? So we just have to probably cross multiply, right? So 0.49 times 101,325, right? We should get a huge number, right? So we're looking at, let's see if this is the right working. It looks a bit wrong, but let's go through it to the end. We should get around 49,649.25, right? And we're gonna have x by that, right? So this should be equal to, right, the volume, right, in dm cube. So we're gonna have 20 divided by what, 1,000. So we got 20 divided by 1,000 to get 0.02. So 0.02. Wait, which volume are we looking at? The gas occupies that, or pressure that. Why is the pressure? Oh, we're looking for P2. Alright, so we're looking for P2. So we have the initial volume. Alright, so let's just start over this. My bad. Let's just start over this clearly. I apologize for that. Alright. Kinda in a rush, but let's look. Alright, so we have P1 V1 equal P2 V2. Alright, we do have the volume, initial volume to be 0.05, right? And initial pressure to be around what, 40. Let me see what we had first. We had 1 atmosphere, 0.49 times, could be times. Let me get something. If we have to convert this, if 1 atmosphere is 101,325, and that means that pascals, that means that 0.949 atmospheres would be how many? So that means that we're going to cross multiply. So 0.49 times 101,325 should give us back the 49649. Right? So 49.25 times that should be equal to this. We're looking for what pressure, right? So what pressure is given when if the gas is reduced to 0.02, right? So we're just going to divide this by 0.02. So let's look at this response. Let's times by 0.05. Right, we should get 248246. So we should end up getting, I'm gonna do this here. Right, so we should end up getting 24824625. I'm just gonna write all the volumes divided by 0.02. So divided by 0.02, we should get 124,130 and 123. So B would be the best answer. Hope that wasn't confusing. Here we're looking at what type of heat change. We're looking at the fact that nitrogen gas has been ionized, right, to produce an electron. So I think this would be the first ionization energy of sodium, right? So sodium, right? I hope I didn't say nitrogen. Sodium gas, right? So we ionize sodium gas, right? Here we're gonna have the different oxidation states, right? So if we look at this, right, oxidation can also be known as the gain of oxygen, so D would be the answer. But you could also go through the different oxidation states, right? So oxygen should be -2, so this should be -4 for oxygen. We're probably looking at the magnesium. This should be +4, and then at magnesium becomes +2 here, right? Here would be -8. That means that this would be +8 for manganese. My bad. And that means that this would be +6 for manganese over here. This will remain -8. Alright. Here will be -8, +8. This should give us a reduced value of +4 and -4. Here now we have +4 and -4, giving us for manganese would be +7 and -8. So note that oxidation can also be the increase in oxidation number, and D is the only place where it actually increases. So That's the answer for this. Kp for calcium hydroxide would Ksp for calcium hydroxide would be calcium 2 plus ions, right? And OH ions squared. So looking at that here now, remember what we do for this. We're looking at the different orders for the different subs. So in an order, experiments where A differs but B remains the same, and we see that we have a double here. So this would be first order. And then here we see that it remains the same. Hold on. If it quadruples, if the rate concentration doubles and rate doubles, it is first order. If it remains the same, it is quadruple will be second order, right? So it is first order here. Hold on, right? So first order, right? We want to look at those equations and how we can define them, right? The different orders of reactions, right? Alright, so I want to look at the orders of reactions in terms of the concentration and rate of reaction. Alright, so I want to look at that, the relationships between them. Right. So for the rate summary, first order the rate doubles, so that would be first order, and there's no effect on the rate for zero order. So there's no effect on the rate here, so it should be first order. It should be 1 plus 0. I'm going to have to have a look at this. Right, 0.1, so the rate, the concentration doubles but the rate doubles, would be first order. The concentration doubles but the rate stays the same, there's no effect on the rate. This should be a first order reaction. I've been writing third for the others. Alright, so let's have a look at this. Let's have a look here. The result of the 4 experiments here would give us these. Right, for propanone, looking for propanone. So for propanone, we have to look where propanone changes but the other remain the same. Alright, so looking for second order reactions, it kind of quadruples. Here we're using Henderson-Hasselbalch equation to find it. Okay. We are also looking here, so the best here would be C. The conjugate base would be one that loses the hydrogen. All the other ones have more hydrogens than their acid, so it would not be conjugate base. Right here, we have to know that for our endothermic reaction, if we heat it, it's going to move to the forward reaction, so it would be brown. And because of the gases, right, if we increase the temperature, if we increase the pressure, they will favor the reverse, so it should be B. Here it would be 430 here. I'm actually doing this paper last. What is the value of Kp if the pressure is changed to it? Pressure doesn't affect. Alright, here we're looking at strontium and barium, right? So what's happening for this one is that we're looking for the precipitation, right? Strontium and barium sulfate should have formed the precipitates, right? Calcium sulfate should also form a precipitate, so it might be D. So I want you guys to tell me which answer do you feel is better. Looking at the ones that most like that forms the more insoluble precipitate, right? Or do you want to include all of them because all of them technically would form precipitates? Here now we would find the square root of this answer, which would be C. Here, right, the answer would generally be 7, right, from the general working out. So we're gonna be finding the concentration of hydrogen ions, right, from using the Ka, right? So we're gonna be using the Ka page of that, right? So you have this here. So let's see, the dissociation constant is 1.0 times 10 to the negative 12, right? So we have that here. Will be the approximate pH of that, right? So if the pH, if this is it, 0.1 times 10 to the negative 2, right, I'll have to find x squared. So we're gonna call this 1, right? So x squared would be 0.1 times 10 to the negative 12, right, times 1.0 times 10 to the negative 2, I believe. Right, so this should give us what's negative 12, right? Plus negative 2. This should give us negative 14. So x squared is going to be 1.0 times 10 to the negative 14. Just two indices, and then we square root that to find x, which would be 1.0 times 10 to the negative 7, and we're going to use this as pH. Alright, let's have a look here again. Here we're going to have 2p products over reactants. We're going to have mole squared dm negative 6 over mole cube dm negative 9. Cancel, gonna end up with per mole dm cube. Right, strong acids don't form equilibrium, and this wouldn't be the best here because it's not a solution of its ions. It should be fine. Right, solubility product, we're looking at shellfish, so rely on this calcium carbonate precipitation for their shells. Now we want it to be precipitating. That means that the ionic product will be low, there will be small solubility product, and there will not be a greater solubility product for calcium carbonate. So 2. Here, right, we're looking which of the following types of acids and bases would provide this titration curve. We have a very low pH, meaning a strong acid, very high pH, meaning a strong base. Which of the following transition have unpaired s orbital is always cobalt and chromium? Which of the following elements of the third period have the same oxidation number in all of its known compounds? Chlorine should have the same oxidation number technically, but let me see. Chlorine oxidation number can change, right, in the presence of oxygen, because it's between negative and this big. No, I think it will remain the same. Right, so if you guys have a different answer, like aluminium, let me see, 3 plus, aluminium should remain 3 plus. Or chlorine gas, no, that would always be by itself. What would would be the difference? Same oxidation number in all of its known compounds. Does aluminium have a different one? I don't think so. Well, aluminium has different oxidation states, so I believe that chlorine would be the best answer. Alright, let's look at this now. Which one of the lowest pH? Here, the lowest pH, remember we're gonna be decreasing. Right, so the pH of solutions will rise. So we do this is alkaline oxide, this is alkaline oxide as well. I think the best one would be that bubbling it through. Right, we're saying for here it should undergo the oxidation. Right, so you're saying that chlorine should displace the others, right? So it would probably be hydrogen bromide and hydrogen iodide. From bromine, this is all true. Gas at 20 degrees Celsius. I think it would be more of a liquid because this is below room temperature ish. So I think it's 1 and 2. The tip of a piece of clean platinum wire was brick red color. This would be sodium, or would be potassium. Sodium is an orangish red. Calcium. Potassium would be lilac. Barium would be green. So I think the brick red would be probably sodium or calcium. So which one would be it? The flame color of calcium would be what? The flame color of calcium, I think it would be orangish red, but sodium would be like a strong, persistent orange thereabout. So I think calcium would be closer. Alright. 37, which of the following statements about oxides of elements in period 3 is not true. Not true for all of them. Right? Because they do turn acidic. This is true, this is true, and this is true. Here, no, remember that, no, with all of these, right? Lead and aluminium form these precipitates, right? And zinc is generally soluble in excess. So here we have a lead and aluminium would be B, zinc would be A. In order to distinguish lead from aluminium, we add potassium iodide to get the yellow precipitate, so this would be D. Here now, a sharp increase from copper to zinc. I think this is because of force only, right? Calcium carbonate decomposes. This is probably because of the change of formation. And here, the paramagnetism would be cobalt, which will best determine the presence of halides in river water. Halides, silver nitrate, because they would give the different precipitates of silver, which are white, then creamish, then yellowish, and then we have chromium as a stronger oxidizing agent. So I ended up actually doing this paper the last, so I think this paper has the most corrections. Right? So this would be it.